Welcome, dear students, to this exciting journey into the world of PCB design using KiCad, where we will be learning the art of creating printed circuit board from scratch. We will cover topics from basics to advanced in this course. We will discuss and practice different rules to keep in mind while designing the PCB. As we move further in this journey, we will be looking into designing PCB for high-speed signals as well as PCB for high-voltage application. So let's get started. First of all, what is printed circuit board? A printed circuit board is a flat board made from a non-conductive material, often fiberglass, that is used to mechanically support and electrically connect electronic components using conductive pathways, tracks, or traces etched onto its surface. PCBs play a crucial role in modern electronics by providing a platform for assembling and interconnecting various electronic components in a structured and efficient manner. The process of creating a PCB involves several steps. The number one is design, number two, printing, number three, etching, number four, drilling, number five, component placement, number six, soldering, number seven, testing, number eight, finishing. We will now discuss these one by one. The first step is the design. The circuit design is created using specialized software. This involves placing electronic components such as resistors, capacitors, integrated circuits, and other components on the board and connecting them using traces. In the design process, the first step is building the schematic. The schematic is the connection of different electronic component symbols. The symbols are placed and are connected with one another with the help of wires. In the next step, we build a PCB where footprints of the components are placed and connected with one another with the help of copper traces. After the design process is complete, the second step is printing. The circuit design is printed onto a thin copper layer bonded to non-conductive substrate. This creates the conductive pathway that will later carry electrical signals between components. Number three is etching. The excess copper that is not part of the circuit design is removed through chemical etching, leaving behind only the copper traces that cross bonds to the desired connections. The step number four is drilling. Holes are drilled into the board to accommodate component leads or pins. These holes are often lined with metal to create plated through holes which enhance the board conductivity. Component placement. Electronic components are mounted onto the board using soldering techniques. Surface mount components are soldered directly onto the board surface, while through-hole components are inserted into the plated through holes and soldered on the opposite side. In the coming videos, as we progress in this course, we will be learning in more details about the through-hole and surface mount components. After the components are placed onto the PCB, then comes the soldering process. In a soldering process, we use a solder wire which is heated. As a result, it melts and makes a connection between the PCB footprint and the electronic component. After the soldering is done, then we test the PCB to ensure that all connections are properly made and there is no short circuit or open circuit. After the testing is done and the PCB is okay, then we do a finishing in which the PCB is cleaned and a conformal coating is done to prevent oxidation of copper traces. Now we will discuss different types of PCBs. We will be making these in our coming videos. There are three types of PCBs, that is single layer printed circuit board, double layer printed circuit board and multi-layer printed circuit board. As the complexity of the circuit increases, the number of layers in our board increases. A single layer PCB has a single layer of copper foil onto a substrate, while in a double layer PCB there are two copper layers, one on the top and the other on the bottom layer. So these are called double layer PCBs. In multi-layer PCBs there are multiple layers of the copper. Overall, PCBs are the backbone of modern electronics. PCBs help the creation of compact, reliable, and efficient electronic devices ranging from smartphones and computers to medical equipment and automotive systems. In fact, every electronic device in this modern world has a PCB inside it. Our main focus in this course is to gain knowledge about the PCB design using KiCad. We will be learning a lot of things regarding the PCB design in this course. In next video, we will be looking how to install KiCad on our systems. So thank you for choosing this course. We will be learning a lot of things in this course.